Okay, this video is to explain a little bit about the math um, IA rubric. First of all, the math IA is worth 20% of the IB grade. The rest are the external assessments, paper 1, paper 2, and paper 3 for HLs. The number of points that are given for the IA is 20. Those are distributed between 5 criterion, A, B, C, D, E. You can see the names of the criterion here. Most of the criterion are worth 3 or 4 points. Use of mathematics, the principal criterion, is worth 6. So that's 30% of the grade, and the rest of it is the other 70%. So in a way, you might say that's normal. Mathematics should be the main part. On the other hand, you might say 30% of the grade, so the math part of it is only worth 30% of the grade, and there's a bunch of other stuff worth 70. So I've had students do almost no math in their math IA, and they can still pass because of the other criterion. They might be able to get 1 point in each. Okay. Moving to the first criterion called presentation. In the previous syllabus, this was called communication, and I think communication is probably maybe a better name for it. But anyway, it's kind of like the non-math part of the writing. Okay, so all the writing and arranging and organization, which is not directly related to the math, is presentation. Here's some instructions, which they never had in the last syllabus, which I think is a good move to include these specific instructions. They tell us that it should be 12 to 20 pages long, which might sound kind of long, but they do ask you to double space. A lot of students write 12 pages currently in the old syllabus, 12 pages single-spaced, and it is very hard to write comments on single-spaced reports. I don't know if that's the reason why they changed it to double-spaced, but you should double-space now. And because of that, they allow you to go up to 20 pages. Word processed or handwritten, but there's no reason why in Brazil you should be writing a handwritten report. Word processed, it's going to look better, even if there is no intentional bias against handwritten reports. There's probably going to be some unintentional bias. You should explain things in a way that demonstrates clear understanding, and we'll talk about that throughout the rubric, but your mission is to show how much math you understand, okay? And if you show that you understand a lot of math, you're going to get a good grade. And if you show that you understand that you don't understand a lot of math, then you're going to, in general, get a bad grade. And even though we say that 30% of the grade is use of math, a lot of the other categories have to do with how well you are making the case that you do understand math. Peers should be able to follow easily. So I often say that 10th graders should be able to follow your work. The reason why I say that is because you shouldn't assume just because it's a math analysis or applications concept that you don't need to go through it. You actually need to explain it as if the person did not know about that particular concept. So that's not your peers, right? That would be 10th graders, students who have not learned that concept yet. So I often say that you should be explaining things as if you were talking to a sophomore. You should have a bibliography. In most cases, it's pretty hard to have data and do work such as linear regression or modeling or chi-squared, things that require a lot of formulas. It's pretty hard to do those without referring to any website or textbook, and so those should be in your bibliography. If you use our textbook, you should put the textbook in your bibliography. Direct quotes. Yes, of course, direct quotes should be acknowledged, but I would wonder why the heck you are putting a direct quote in a math IA, okay? Oftentimes I see people citing math explanations out of a textbook or a website, and that is about the dumbest thing you could do in a math IA, because you've taken an opportunity where you could have demonstrated your math understanding, and instead you copy word for word an explanation by somebody else, which absolutely shows no understanding. So you shouldn't really be using direct quotes anyway, okay? All right, so here are the 5 different levels for category A, 0, 1, 2, 3, 4. The top level is this explanation is coherent, well organized, and concise. It's, looking at this, you might think, why would anybody get less than a 4 in this category? But actually, most people get less than 4, okay? All right, let's look at some of the other things I've highlighted. Okay, your IA should meet its aim. So at the beginning, you should talk about what the aim of the IA is, and at the end, you should show with math how you have met that aim. You might say, how could someone not meet their aim? Well, usually the most common way is that they write their introduction 3 months before they write the conclusion, and they never go back and fix the introduction. Sometimes they've changed the aim in the middle of the IA, and they don't go back and update it. So that's usually the reason why you don't meet your aim. Yeah, the introduction has the aim. The exploration, or that's what they call the IA, of course, has a conclusion. Appendices, how should they be used? Appendices should be used to include things like raw data that take up a lot of space, and maybe you're like unsure about whether it should be included. You should put those in as appendices. If you do have an appendix, you should definitely refer to the appendix in the body so that people can jump to the appendix at the appropriate time. If you never refer to the appendix in the body, then probably the reader is never going to go look at the thing in the appendix. Okay, so you at the appropriate time you should say, okay, go see Appendix A because that's where my raw data is, or something like that. Okay. On the other hand, graphs and things that are not that big and are important to your case should be included in the body and not be put in the appendices. Repetitive things, that's one thing you should maybe put in the appendix. If you have, like, let's say that you have 5 calculations that are identical with different numbers, take up a lot of space, do the first one in the body, and the other 4 you could put in the appendix and say, hey, go look at the appendix if you want to see every single calculation, and the results are here in the body. Technology. So you have to be thinking about, okay, what is my objective here? What is the main math process I want to show? If you don't have a lot of math processes, probably you want to make sure that you have one math process done using analytic non-calculator method, explaining everything to make that the centerpiece of your IA. If you have many math processes and you're kind of integrating them all, and your main story is not focusing on one math process but like on a narrative you're creating with many math processes, in that case maybe what you want to do is use technology as much as possible so that you can center on the whole story and not center on one little math process. Okay, and so the parts in italics here are parts that I have read in other sources, mostly from other documents from the IB. It's called Teacher Support Material, TSM, and about each category. So the bold part is what's actually written in your guide, and the italics parts are things that I added from either the old guide or like some other supporting documentation. So in category A, we're talking mostly on the non-math ideas and concepts. Sometimes like you're introducing your hobby or whatever, and you should explain your hobby well. That would come under category A. You don't need to sit there doing headings for each separate paragraph or section. That is totally unnecessary. why not have a cover page? I noticed this year that a lot of students didn't put cover pages. I didn't understand that. A cover page makes the thing look better, and it gives a place for the teacher to write stuff. So definitely want a cover page. The cover page doesn't count in the page count anyway, okay? So go ahead and put in a cover page. Now, table of contents you really do not need, okay? But put a cover page. Meaningful title, you should, every year there's one person who puts Math IA as their title. Yeah, that's a big mistake. You should ask an interesting question, which means that it's not a question, it's like an extended essay question. It doesn't have a yes or no answer. Your Math IA should also ask an interesting question where, or maybe it could be a yes or no answer, but it's not a question where everybody already knows the answer. If everybody already knows the answer, if you know the answer, why the heck are you even doing the Math IA about that? It's not interesting. Your graphs and tables, etc., diagrams, they should be calculations. They should be interlaced in the text, not like put a whole bunch in a row. You should have text, then you should have whatever you're doing, and then you should have text again. Kind of like the way I want you to write your blogs. Proofread by another person. This, the big obstacle is people usually do their last version at the last minute, so there's no time to show it to anybody else. But there's always like one sentence in a really good IA where they only wrote half the sentence and they didn't finish the sentence. It's really hard to find those on your own. Somebody else reading it, they're going to find it in an instant. Let's see. When you do technology, you are not expected to write down the technology how-to guide like we do in a blog. That is totally unnecessary. On the other hand, if you're solving it by hand analytically, you do want to put a how-to guide. But technology, just say you did it with technology, and that's it. That's why it's so hard to show that you know something about math with technology, because basically what you're going to do is just show the answer. Always put pages on your document. It's not a requirement for the IA, but it sure is difficult for me as the teacher to tell you which page the mistake is on if you don't put page numbers on your IA. I already said about direct quotes that you shouldn't use direct quotes, okay? Section B, math communication. There are 5 levels from 0 to 4. And this is kind of like the same thing as category A, except here we're focusing on math-specific type of communication. So let's look through the highlights here. Obviously, notation, symbols, and terminology. Something that people often do on their blogs, which I always count off for, is they put the caret symbol for exponents, things like that, rounding wrong, not putting 3 significant figures. All the things I take off for in blogs, I take off for because I don't want you to do it in your IA either. You should define your math terms and variables. That's a good math presentation. Actually, what is it called? It's called math communication. Before it was called math presentation. Formulas, diagrams, charts, graphs, and models. So those should all be used appropriately. When there's a time when you should use each of these, you should use them at the right time. Again, minor errors in all these categories shouldn't keep you from getting the maximum level. You could still get the maximum level even with some small errors. Use technology appropriately at the right time. It's encouraged, in fact, as long as it's at the right time. Make sure that, or this is actually for the teachers, but the teachers are instructed not to take off twice for the same thing. So if there's like some kind of format or communication, presentation issue, you either take off for it in category A or category B, but not in both. Yeah, I already talked about this, rounding 3 significant figures. That is something you need to be careful of in category B. Category C, personal engagement. This is sometimes hard for students to understand. how you show personal engagement, but you do not talk enthusiastically. You do not try your darndest during the process. Those two things don't demonstrate math personal engagement. So what does show math personal engagement? First of all, there's 4 levels, 0 to 3. And there's some verbiage here, especially like quotes from the old guide, which are not included in the new guide. I include them here because I thought they're kind of helpful. One thing and one instruction they tell teachers is that you should be judging personal engagement from the perspective of a teenage student and not based on like what an adult or teacher can do. So making it your own is a good phrase to be thinking about. It's like, why is your IA totally different than everybody else's IA in some way? Okay, why is it that your IA is going to be the only one that's like that among the 150,000 math IAs? If the answer is it's not different, then I think you've answered your own question that you're not going to get the maximum grade in personal engagement. Thinking independently, creatively, using different perspectives, making a prediction. Making a prediction is something that shows personal engagement because maybe the reason why you're doing the IA is because you have a prediction or a theory that you wanted to test. Okay, so that already shows like that's probably going to make it unique, and that's going to make you interested, and that's probably going to bring out the best in your problem solving and math ability. Teacher comments that the student was highly engaged. That does not show personal engagement. I don't write things like that. Textbook style explorations. If you are looking for your IA on the internet, that is a really bad sign. You are probably destined to have a mediocre IA, even if the reason why you're looking online is to try to copy a 7 IA. If it's not your 7 IA, it's somebody else's 7 IA, you are going to get a 4, okay? So, or worse maybe. So if I tell you that, oh, this is like an IA that, anybody, they're going to get 3,000 IAs that are like this, then that's okay if you're going for a mediocre grade, a 4 or something. But if you're trying to get a high grade, 5, 6, or 7, don't do that. Okay, it's a lot easier just to be true to yourself and choose something that is interesting to you. It will come out more unique and personal, and you'll get a lot of points just through personal engagement. Okay. Obviously, when you say what topic you're going to do, you should say why it's interesting to you. Why did you do it? We don't do these usually at EAC because I highly discourage it, but I've seen sample IAs where people just talk about discoveries made by famous mathematicians, and they think that putting it in their own words makes it their IA. I think that's a really good way to get a mediocre grade. Let's see, besides boring yourself to death. Making the link between your hobby and math, that is a really good way of showing personal engagement, especially if it's something, again, unique. Generating your own data, that's something that can show personal engagement. Okay. Category D, reflection. So reflection has 4 levels, 0 to 3. And basically reflection is typically what we think of as like conclusion, analysis at the end. But actually math IA reflection is something that could happen throughout the IA, especially because like at the very beginning you might have an idea where your IA is going, but once you start working on it, it kind of takes a life on its own. You start doing things, maybe the second step was not what you expected to when you did the first step. Third step, definitely not what you expected. But so how did you figure out what to do on the second and third step? You reflected on the first step. You reflected on the second step. Then you made the decision on what to do on the next step. That is definitely reflection which occurs throughout the exploration, okay? Reflecting on each result as you get it and then showing how that led to the decision to make the next step as opposed to like some kind of recipe in which you just, followed the steps that were given and you went all the way to step 15 and you never changed anything, okay? Okay, one important thing about reflection, you should always be thinking about, reflecting about how you accomplished your aim or how you answered your question. If you are not tying it back to the aim on the first page, then what the heck were you doing all this time, right? I mean, wasn't the whole point to accomplish your aim? A lot of times people will say their aim is like finding an equation model, and then at the very end they get the equation model from Desmos or something, and they never even like write the equation down. They never analyze a coefficient. And then at the end, you're kind of like, did the person really want to find the model? Because once they found the model, they did nothing with it. Okay, so you really want to link back to the aim. When you reflect, you want to analyze what you got out, and you want to show that you understand it and how it's valid, et cetera, et cetera. Okay. So yeah, the mathematical results that you get should be the focus of your reflection, not your raw data. A lot of times people focus too much on the raw data. They just are critical of their raw data. They analyze their raw data. They make connections with their raw data to their aim. It's like, okay, the objective of the Math IA is not to collect raw data. It is to use the raw data in a math process to get a math result. Analyze the math result, not the raw data. Okay. Implications of results. Yeah, make connections with the result, with the math result, back to your context. Show that, in your context, the y-intercept is equivalent to this non-math concept. The slope is equal to this. Say how that number could be used by people in the industry to, improve some kind of process in the context, et cetera, et cetera. So, okay. Let's see. I talked about that. Make conjectures, analyze them through the project. Yeah, like make predictions. Making predictions means that you have a lot of intuition about the subject area, which helps in personal engagement. And then it shows that you're reflecting on the evidence you have and making predictions about what's going to happen later, right? Analyze choices made during the project. Yeah, so that's something you should definitely do when you do reflection. The math processes you chose to use those. You already explained why you chose to use them. After you do them, you probably have an idea of whether or not you made a good decision or not, right? Last of all, category E, use of maths. So there are 7 levels, 0 through 6, okay, 30% of the grade. Let's go back and look at these highlights. So if you do something like linear regression using the calculator, which is something we can do in like 5 or 10 minutes, that is a math process. It's just that it's a math process in which, if using the calculator, shows basically no understanding. So you would score like 1 out of 6 for doing linear regression with the calculator. Of course, you'd only spend 10 minutes doing your IA too, so maybe that was your goal. Let's see. Make sure you understand that demonstrating understanding is not getting the correct answer. In fact, you could get the wrong answer and show understanding by recognizing that you have a wrong answer, right? But a correct answer is, that helps, but just getting the correct answer and not showing work shows no understanding, okay? Next section, math, use of math. You are trying to show math understanding, and you are probably doing it throughout the IA. Let's see. Relevant. Usually people do more than one math process, not because you have to, but just like in the natural course of things, usually you're going to do 2 or 3 math processes to accomplish whatever aim you're looking at. Just make sure you don't bring things into it that are not really important to accomplish your aim. You just brought it in because you wanted to have another process, or you wanted a process that was more difficult. Math teachers are going to recognize that you just did it for the sake of doing it. they're going to see that it wasn't really important to your aim, unless you modify your aim so that it is relevant, okay? But it's super important that the things that you chose are make sense to use. And like using a cannon to kill a fly instead of a fly swatter shows lack of understanding, not understanding. So if you use non-right triangle trigonometry to solve a problem that could have been solved with SOHCAHTOA, guess what? That is going to work against you. It's going to, if you use the law of cosines instead of sine, instead of like simple sine opposite over hypotenuse, it shows that you didn't recognize that there was a right triangle there, so you used the wrong law. Okay, that doesn't show math understanding. Let's see. So prior learning is the page of the formula sheet that basically is like formulas that you should have known from before 11th grade. You shouldn't be just using those formulas. That's a bad sign. So you should be doing things that you learned during the course or something equally difficult. So when you demonstrate your math understanding, you should be doing that by showing your reasoning process, explaining the decisions you made, talking out loud while you're doing your analysis, not just saying results, okay? Explaining how you got the result is usually something that shows that you understand what you're doing. Let's see. Again, occasional minor errors are not usually enough to take you out of the running for the maximum level. So if you use technology, it becomes all the more important to do a thorough explanation of the pre-technology phase and analysis of what you get out of the technology, because that's the only way you're going to show your understanding in the technology phase, before and after, right? You don't have to use a certain number of topics in the IA. That's a myth. You can just do one topic really, really well. Probably in the process of doing that topic or subtopic, you probably end up doing other math processes also. But just, be natural. Don't like sit there trying to invent excuses to do an integral or whatever. Or if you are going to do that, definitely talk to me about it and see if it's actually relevant. And if it's not, then you need to make it relevant to the aim, okay? My comments on use of maths. Okay, it definitely needs to be proofread to see if the math is correct. Your one chance to do that is on the rough draft. Okay, on the rough draft, I'm going to do a very thorough job of making sure your math is correct. If it's not, I'm going to point out to you where the mistakes are. Any math you add in between the rough draft and the final version is taking a big risk, because nobody is going to look at that math. Even if I look at it with verbal feedback over your shoulder in 5 minutes, there's mistakes that I'm not going to see. Okay, so I highly encourage you to put all the math that you're going to put in it by the rough draft, and don't add a lot of math in between the rough draft and the final draft. When you introduce a math concept, you need to explain each math concept, again, as if you're talking to a 10th grader, which means that they don't know the concept yet. You need to explain the concept in your own words. You also need to explain why that math concept was chosen. That is something that is really difficult for you guys. You're like thinking it's really obvious why you chose that math concept. You need to explain from the point of view of your aim, why was that math concept necessary to accomplish your aim or answer your question. Okay, even if you think it's super obvious, you need to say it. Otherwise, you're not going to be able to get the maximum level here. Okay, and I think that's it. So sorry for that really long explanation, but I kept it under 30 minutes. And I hope that you enjoy doing your IA.